Artificial intelligence is the hottest new thing in technology right now, but my next guest says there's something else we should be paying attention to: quantum computing. It is an emerging field that aims to use the weird properties of quantum particles to make computers that have vastly more processing power than computers have today. And that could help us solve all kinds of difficult problems. I spoke to the famous physicist Michio Kaku, who has a new book called Quantum Supremacy: How the Quantum Computer Revolution Will Change Everything. Michio Kaku, welcome again. Tell me what your take on the AI chatbots, ChatGPT, that everybody is so obsessed by now.
I think the media is hyperventilating over the implications of these chatbots. First of all, they are productive. They're going to speed up the ability to produce materials. It's going to be an advance for society in general. However, people are focusing on the negative aspects of chatbots as well, because people are afraid. However, what is a chatbot? A chatbot is a glorified tape recorder. It takes snippets of what's on the web created by a human, splices them together, and passes it off as if it created these things, and people are saying, oh my God, it's a human. It's human-like. The chatbot simply rearranges what's ever on the internet already. It's a tape recorder of a very advanced type that does not understand truth, what is false, does not understand slander versus reality. That has to be put in by a human.
So the real shift that you say is going to take place is once we get to quantum computing.
We've gone through three basic stages of computer revolution. First stage was when we computed with sticks, stones, levers, gears, pulleys, string. That was the first stage, the analog stage. Then comes World War II. At that point, we switched to electricity, and we switched to transistors, and that gave us the microchip and the digital revolution of today. We're in stage two.
Which is the ones and zeros, the bits and bytes.
That's right, zeros and ones, zeros and ones. But Mother Nature would laugh at us because Mother Nature does not use zeros and ones, zeros and ones. Mother Nature computes on electrons, electron waves, waves that create molecules. And that's why we're now entering stage three. Silicon Valley could become a Rust Belt unless they get on the bandwagon.
But would it be fair to say that the shift that you're describing, quantum computing, basically we are now trying to mimic what nature does, because an electron is not a particle, it's a wave, or it's sort of both. And that's where computing has to go.
By God, I think you got it. That's exactly what we're talking about. Because, for example, take a look at a transistor. A transistor has two states, up and down, left and right, true and false. So think of an atom that spins either up or down. Two states. The digital revolution is based on that idea. However, a quantum computer can be at any angle. Now think about that. There are infinitely more states that you can create if an electron is allowed to wobble and point in any direction whatsoever rather than up or down.
So a quantum computing is a computing using not computer chips, but using these waves or these...
That's right. The various states of these waves can vibrate in any direction, and they're simultaneous, so that it can actually calculate 2 or 3 places at the same time. So think of a mouse in a maze. A digital computer would calculate the trajectory of each mouse at every joint, at every place where there's a decision to be made in a maze. That takes forever. Now, quantum computer instantly analyzes all possible modes, all possible trajectories simultaneously. Now, that violates common sense. Common sense says you cannot be 2 places at the same time. Well, get with it. In the quantum theory, you can be many places at the same time. And that's the power of quantum computers.
What would it look like? Would my laptop look the same?
When you look at a quantum computer, it's like a chandelier, a gigantic device, but the actual computation is done at the very bottom. What is this chandelier? The chandelier is cooling pipes. cooling pipes to bring it down to near absolute zero where there's no vibrations. If somebody sneezes a block away, that could ruin your whole calculation. And so you want everything to be frozen near absolute zero.
What I'm also struck by is, tell me if I'm wrong, when you hear about all this artificial intelligence and the amount of computing power you need to produce this stuff, and the amount of energy you need to run all these computers, I always think, God, the brain is very energy efficient. We're able to make all these calculations. We don't need all this cooling. We're somehow doing it using much less energy than these vast computers with all their heat.
Mother Nature is still ahead of us. Our brain is the most complex object in the known universe. We know of nothing in the universe more complex than the human brain, which has 100 billion neurons, each neuron connected to 10,000 other neurons, and it's all done at room temperature. And so we're playing catch up to Mother Nature. Mother Nature is quantum. And that's what we have to make the transition from digital computers to quantum computers. And that'll allow us to calculate diseases, for example, that are at the quantum level. Cancer, Parkinson's, Alzheimer's disease. These are diseases at the molecular level. We're powerless to cure these diseases because we have to learn the language of nature, which is the language of molecules and quantum electrons.
Michio Kaku, always a pleasure to talk to you.